All right. Can you see my screen?
Yep.
Awesome. Hey, everyone. So I'm Darius Liktorius, and I just changed roles inside of PwC. So I was the Senior Director of Solutions Architecture on a very large project, and I moved over to be effectively, I'm still a Senior Director, but I'm a business owner now of multiple products inside of Global Data Services at PwC. So I guess we should update this slide. But that would have been boring, right? Like coming to hear a business owner speak, like that would just be horribly boring. So let's not do that. So anyway, so the overall history of my background has just been a data-centric focused background for some time now. Yeah, so my history and my background has almost always been centered and focused around data. I've been using SQL Server since 1995. Prior to that, I used FoxPro, Access, and Paradox, and some DBase, and all kinds of different types of databases prior to that. So I think I've always enjoyed working with data. However, my background has been pretty balanced out and rounded around not just data, but also application development and also even infrastructure. I was involved even one time in a data center build out. So I'm pretty familiar with many aspects of technology, but data is my passion. One of my hobbies on the side is photography that at one point almost took over my technology career. And on one hand, I regret that it didn't. On the other hand, being a photographer isn't easy while you have a family of 6 to feed. So anyway, yeah, I do have 4 children, so my life's been kind of busy. I do have a question. If anyone's willing to just share about you, like I would love to hear if anyone's a DBA in the chat. Feel free to put that in here just so we kind of get a sense of what your background is. Feel free to share what your current role is and what you focus on. Also a DBA with 4 kids. Awesome. Thanks, Alex. So how many of you are database or BI developers? How many of you use Fabric? How many of you use Power BI? How many of you have used Data Factory or any of these various technologies or SQL Server? Feel free to share. That'll help us with tailoring the presentation a little bit. So today, what we're going to do is we're going to talk about a couple different things. We're going to start with a data engineering primer for those of you who are not familiar with some of these concepts. And even if you've been in this data space for some time, things have been changing. So it may just be a review for you, and I apologize, but for everyone's benefit, we'll go through it. But you may pick up 1 or 2 tidbits along the way. We'll also go through Data Factory itself, an introduction to it, both Data Factory in Azure and Data Factory in Fabric, and how those two relate. And we'll also focus a little bit on Fabric and something that's known as task flows inside of Fabric, which is not to be confused with Data Factory, but nonetheless makes use of Data Factory directly. So we'll look at that. And we're going to define and compare and contrast the different components of Azure Data Factory versus Data Factory in Fabric. So then we'll have some demos on both of those. And we'll go over some pricing and questions and answers. And happy to, go through that here. Thanks for sharing, Raphael. Data engineer, 2 children. Awesome. So data engineering, a primer on this. We talked about we would want to discuss terminology. So many of us have probably heard of ETL, which stands for extract, transform, and load. So we extract data from a source. We may transform it. And what that means is we may change the data types. We may change the name of the columns for that particular field. And then we're going to go ahead and load the basically resulting result set into the destination. A more modern approach that makes use of something known as a data lake, which we'll go over here in just a second, is extract, load, and transform. So what we do first is we extract it from the source. We load it into, let's call it a semi-permanent loading staging area. And we basically then transform it further if needed and make that data available to consumers down the line. There's also the concept of data mapping and wrangling. So basically this is, mapping one source column to a destination column and, basically identifying the, set of data, the result set and the schema that we want to go ahead and actually transfer over to a destination somewhere or to more than one destination. Alex raised his hand, just making sure you don't have a question. If you do, feel free to ask in the Q&A section. And then we will also cover here, what is a relational database, right? A database that has, tables and basically has a relationship. And the best relationship that's almost always given is I have a table of orders and the order definitions. I may have a header in that table for the customer information and so forth, right? And then I have a table of order line items. So every single line item in that order, what the quantity of each item is, etc. And then there's a data lake and medallion model, which are more modern, basically next gen data storage terminologies and technologies, which started about, I guess, 5-6 years ago, the concept of a data lake. And the medallion model allows us to structure the data inside of that lake. So if we take a look here, we've got a couple examples here, the difference between ETL and ELT. So what we have on the top is the traditional ETL workflow. We have sources of data that we extract from. We transform that data inside, often using some staging tables in between, and then we load that data sometimes into our operational data stores, right? We're ingesting data that's relevant to the operational on OLTP transactional databases, but we also will load that data into a warehouse for analytical purposes, perhaps, right? And we'll, examine and visualize that through Power BI or through some additional apps that are further consuming that data. And then to contrast that, at the bottom, we have the ELT, extract, load, then transform pattern, which fits into the next gen data lake medallion type model approach. And what this basically shifts and pivots the load and the transform around. What you're doing is you're extracting from some source and you're using a pipeline to load it into no longer a staging table or set of staging tables, but you're actually loading it into I'll call it a semi-permanent. It most of the time is permanent, but it might be purged in some way, shape, or form. That's why I mentioned that it might be semi-permanent landing area, which is basically your bronze tier inside of a medallion model. And the medallion model basically says I have 3 categorizations of my data and what level of maturity that data has inside of my data estate. So in the case of a bronze tier, you have your raw data that's coming in from your various sources. It has not been transformed. It has not been cleansed. It has not been validated. It's literally the raw data as it's coming in from CSV files, from databases, or IoT apps, etc., that might be streaming that data in. And that data basically arrives in the bronze tier. It keeps getting appended to, typically, you retain all the data that's coming in. And then you have a transformational process in the form of a pipeline, typically running in some type of compute, which we'll talk about in a little bit. And that compute will basically go ahead and transform your bronze tier raw data into your silver and eventually your gold tier. And what that does is basically the difference between your silver and your gold tier is your silver tier is kind of an intermediary tier where you have sanitized and you've cleansed and you've verified and validated your data. You have standardized on the data types for your data and so forth. You may have converted, say, a string into a numeric. And if it failed to convert, that row of data or that entire data set does not come across over to the silver tier and therefore is not yet a candidate to the gold tier. So the silver tier is a key tier to make sure that our data is cleansed and sanitized. However, the data is generally still in the same form and in a one-to-one relationship with the data entities or tables that came in from the raw bronze tier. So if we have table A, it's still going to be table A. It may have all of the same columns or a subset of them. Generally speaking, it has as many columns as you can retain. You're not looking to eliminate data in your silver tier. You're simply looking to have a cleansed, cleaned up, validated view of the data as it arrived in that bronze tier. And then you can take that data and you can transform it further, map it to different field names, column names, more friendly names. You may also take data from different tables and you may denormalize it into a table that contains data from both source tables. Or you may just bring data over one for one. It depends on the use case. It depends what the goal is. But that gold tier is the tier that actually gets consumed by consumers down the line. So applications or Power BI or some other database that you need to now take that and further import that gold tier into. But this is essentially the modern next generational data estate warehouse type of approach, which is we're taking data from disparate sources, we're cleansing it, sanitizing it, and we're preparing it and we're finalizing it into a gold tier. And you'll notice that my gold tier here at the bottom has something described as a CDM. That's known as a common data model. And so a common data model is something that your organization has agreed upon to be that final view, that final, shape of your data across all of the different entities that you're looking to present. And not to get too confusing here, but I just want you to be aware of this possibility, is that your gold tier could be your gold tier can become the bronze tier of someone else's medallion model. So your gold tier could eventually feed some other bronze tier out there. And there's something known as a data mesh technology approach or strategy to your data estate. And you basically have different data lakes, and you're able to progress your data through these various processes. So I just want to take a stop right here before we continue and take any questions, because this is a pretty loaded slide, and I just want to make sure if anyone had any questions. Feel free to ask. Anyone? Okay. You're still with me, right? Just making sure. Cecilia, can you hear me?
Yes. Sorry.
Okay.
The microphone. Yes.
All right.
I see a question. Someone
You do?
again, yeah, Alex saying.
Okay, I just opened the Q&A. Do you typically, okay. Yeah, okay, I see the question. Do you typically keep your silver and gold tier as the same data lake, or do you create a separate one for gold? So that's a great question. So Alex is asking if you can have these different tiers be in the same data lake, and what he's referring to is the same storage account. So in Azure, it would be the same Azure ADLS, basically data lake structured storage account. And the answer to that question is, in a smaller environment, you could keep all three of these in the same storage account. You could have them in different containers. You could have a bronze container, a silver container, and a gold container. I will tell you that where I work, we actually have these all separated out into different storage accounts, not only for security purposes, but for throughput purposes. So think of it this way. And by the way, one thing I should take a step back at, and thanks, Alex, by the way, for the question. I'll continue on this. But one thing I do want to take a step back at and explain is that the storage of a medallion data lake is separate from the compute. So we've taken the traditional warehouse that you would think of as, you'd have SQL Server. It has MDF and NDF files that get attached to that process inside of SQL Server, and no one else can touch those files except for the SQL Server process. But in a data lake and in the medallion model, you have the compute that is separate from the storage. inside of a lake, if you were to look at how this data is stored in these lakes, what you are looking at is a bunch of basically binary files that are known as Parquet files, spelled Parquet, but pronounced Parquet. It's Parquet. Some people call it Parquet. It's Parquet. And the Parquet files are basically compressed, deduplicated tabular data structure files that allow you to store data in separate files that get rolled up into one table. So one table of data is made up of multiple Parquet files. And you can have schema definitions on top of these Parquet files, as well as transactional atomicity like you do in a traditional relational database inside of the lake that is managed by the compute. And oftentimes the most popular format that's used today, I should probably add a slide for all this, and I will next time, apologize. But what you have is you have Parquet files with a Delta Lake schema and structure and format that compute can use and understand. And that Delta data, the Delta Lake, not to be confused with data lake, but a Delta Lake format is actually it's metadata that is stored next to your data in nothing other than other Parquet files. So you have compute, which can read that, and the types of compute that read that you may have heard of before. You may have heard of Databricks. You may have heard of Spark. You may have heard of Synapse. Synapse, Spark, jobs basically, and notebooks that you can run through Synapse. So all those are basically Apache Spark workloads that can access those Parquet files. They understand the Delta Lake format, and they can work with those files and the Delta Lake metadata to store transactionally consistent data across all these Parquet files. You might ask, why are the Parquet files split up like this? It's to enable compute to load up multiple Parquet files simultaneously and do so very quickly so that they're not having to wait to read in one large file. It can read in a bunch of multiple files simultaneously, and the files that it deems that it needs to load to return the results of your query. And some workloads like Databricks will actually cache the results of those files and keep them in memory and cached until any of those files change so that it can very quickly return subsequent results to your queries. So by decoupling the compute from the storage, you are actually enabling multiple workloads to simultaneously manipulate the data and or query the data in your data lake. So this is a brave new world, right, of really scaling your data. And so to Alex's question, the fact that you can separate these tiers out into different storage accounts, you end up with the ability to scale it even further. So think of it as, if you have to read from one tier to another and write to another, so I'm reading from bronze and I'm writing to silver, if I'm writing back into the same storage account, then I'm doubling the amount of IO that's going, in and out of that same account. So you ideally would like to store it on separate accounts if you can. Keep in mind that Azure storage accounts at a base cost are free. It's what you use and what you consume, how much data you store in there, and how much data do you read or write from them. That is going to be your billable event. And so in the case of this model, if you split it up to 3 accounts, you don't have any additional cost in doing so, but you just gain performance. So I see another question from Alex Garcia. Are we able to move Azure Data Factory pipelines into Fabric Data Factory? That's a good question. I believe you can. You can import that. Is that, Jeff, you said that you cannot from Microsoft? That you can't do that?
I asked that question specifically, and I was told no, that there's no way to migrate them. Even though they're similar, they do have a base different code and how they operate.
Okay.
So you can't extract them and put them in. We'll have to build them again. Most everything is supposed to be there, but they have modified, I guess, the back end and how it communicates to some degree. I haven't done a comparison of apples to apples yet, code wise or JSON wise for configuration, but I was told no, and it didn't seem like they were going to also offer that as an option.
There is actually a decent amount of overlap, so I'm disappointed to hear that they're not going to be doing that. Obviously,
Yeah,
for folks,
I was too, because I figured if they wanted people to move to Fabric, I would have figured they would have made it easy way to bring that over.
I would imagine they'd have to do some kind of translation tool or something soon. All right. Well, thanks for that context, Jeff. I appreciate that. All right. So let's move on. So we have let's look at the intro to these. So for those that have not used Data Factory at all, it's basically a Microsoft offering to perform ETL or ELT workloads by creating pipelines that you create a workflow, and basically it runs in the cloud, so you don't have to run it on your own, compute, but you can run it in your own compute by creating what are known as integration runtimes, which we'll talk about later, and run that inside of your own virtual network inside of Azure or inside of another cloud provider or even on premise. And you basically, the goal of this is to perform your ETL or your ELT, and you're copying and you're transforming your data. And so this allows you to tie all of those steps or tasks along the way together. There's numerous integrations and connectivity options to Data Factory, and we'll go through all those together. So again, there's two flavors that I've talked about. There's an Azure Data Factory, which is a standalone platform as a service offering known as a PaaS offering. It does have additional integrations and configurability than what's offered today in Data Factory inside of Fabric, which is the second type of implementation and platform for Data Factory. So I'm coining it DFF. That's my own acronym for it. So if you hear me refer to DFF, so I don't have to keep saying these, in their comprehensive names, I'll shortcut ADF and DFF. So DFF is a software as a service offering that resides inside of Microsoft Fabric, which we'll talk about a little bit more here as a platform. For those of you that are not familiar with Fabric, it is basically a platform that Microsoft has created that they have based on top of what was originally the Power BI tenant. And the Power BI tenant is basically being used as a management plane to orchestrate these various workloads. So they've taken different pieces of technologies that have been separate to date at Microsoft in Azure, like Data Factory or a warehouse or Spark compute workloads or real-time streaming and intelligence, and they basically integrating that plus more inside of a single platform that you can predominantly use the user interface for to go ahead and actually tie all of your data together. And there are some gotchas to it, and it is a new offering, right? Microsoft just released it within the last year, and it is evolving quickly. There are a lot of good things to it, though. I don't want to belittle it at all. I just want you to be aware of that it is a new frontier. So there is all of these technologies are tied together and ultimately depend on this tier that you see here as a single data foundation, which is OneLake. So OneLake is a Azure blob storage or ADLS data lake compliant interface into a very large, call it a super data lake, that allows you to have separate workspaces and separate security, delineations inside of OneLake for your data. So think of it as if you've got, and OneLake actually, without going into too many more details, it would probably be good to add a whole slide on OneLake alone. OneLake can store the data within OneLake, but OneLake can also use shortcuts to data that's residing in other lake storage providers such as Amazon S3 or in Google Blob Storage. And you can tie it into OneLake without actually transferring the data into OneLake. So Fabric can access your data that's sitting in S3 or your data that's sitting in Google without having to actually copy it into OneLake. So that's a very cool feature for OneLake inside of Fabric. So what we're going to focus on today, some of you, especially with that are frequent visitors of Cecilia's group, are probably very familiar with Power BI. We're going to focus on the first box here today, which is Data Factory, because without data, there's not much to do inside of Fabric unless you've got the data into Fabric, right? And so we are going to focus on Data Factory, but we are also going to look at, like I said, Data Factory inside of Azure specifically as well, in case you don't use Fabric. And we need to look at the differences between those. So Data Factory components. And what I've done here is I've highlighted in green the Fabric equivalent name for every component inside of Data Factory. So the Data Factory is a data factory, whether it resides in Azure or whether it resides in Fabric. However, a pipeline is referred to as a data pipeline inside of Fabric. Activities are still activities, and mapping data flows are known as data flow Gen 2 today inside of Fabric. And data sets, there is no such equivalent. So we'll talk through real quick what these are. So a data factory basically is the shell that contains all of your definitions. Pipelines are the definitions of your timeline of your workflow that you want to tie together, different tasks together to accomplish something within your data factory. Activities are the individual activities within the pipeline. You can think of them as your tasks. And then separately, a mapping data flow or a data flow Gen 2 isn't really directly, think of it as an alternative to your pipeline. It's not, you can call into a data flow from within your pipeline as an activity, but the data flow itself is a new form of pipeline. And one thing to note is that your pipeline activities run inside of a data factory specific compute known as an integration runtime, but your data flows run inside of a separate compute. And it explicitly, a data flow is nothing more or less than a graphical representation of multiple steps that can be written hand-coded into something known as a notebook that runs inside of Spark. And remember, Spark can be Spark, it can be Synapse, Synapse Spark jobs, it can be Databricks notebook jobs that you run. Any type of Spark workload is essentially ultimately what data flows are. They're just a user interface driven, a graphical user interface driven way of authoring Spark notebook workloads. And then data sets inside of Data Factory, not in Fabric. You don't have those concepts inside of Fabric. I think they just took them away to make it easier to work with. And that was always something that was frustrating in Data Factory, was having to work with data sets necessarily. They're kind of somewhat irrelevant more often than not. Data sets are just a way to define a source or a destination and what columns exist in it. And we'll take a look at that. So further, we have templates that you can use inside of both data factories that Microsoft has provided, or you can create your own and save as a template. Looks like we have a question. Let me take a look really quick. Jeff, didn't they rename data sets as semantic models? Yes and no. So I guess they're using semantic models in place of a data set, Jeff. But for those of you who are familiar with Power BI, they called data sets were a different type of they were like a Power BI construct, right? So I guess you could say it's fair to say that the data set represented inside of the data factory and Fabric is one and the same, but since it was renamed to a semantic model, I guess you could argue that it's separate. But I don't want to get too technical, but Jeff, you may be familiar with SQL analysis services, and analysis services has a VertiPack engine, and a VertiPack engine and file format was used by Power BI and analysis services to have data inside of a data set. When you import data inside of Power BI, instead of doing a direct query, you had an import mode. And that data set representation of that data in an import mode approach was running an entire VertiPack engine on it. And it still does that today, but they call it a semantic model. So it's a bit different than what a data set was inside of Azure Data Factory, which was nothing more than basically a schema definition. It didn't actually run inside of a VertiPack engine. So while they have similar use cases, I think they were very different in what actually is happening with those data sets. Hope that helps. So linked services. Linked services are basically the connections and the glue that ties your source and your destination data, locations. So you may have a source that might be a blob storage location, or it may be a database, and your destination may be something else. Or your source may be a web API of some sort, and your destination could be a database or a file. So that's what ties your different data set locations, and your pipelines can go ahead and use those in those activities. And then you had the ability to trigger on a schedule or on demand your pipelines inside of Azure Data Factory. They call those schedules inside of Fabric. And then integration runtimes, like I mentioned earlier, is basically the compute that runs all of the activities inside of a pipeline, except for data flow activities. Your data flows may get triggered from an integration runtime, but they actually run inside of a Spark workload like Synapse. So in Fabric, they're calling these integration runtimes on-premise data gateways, is basically what they're calling them here. So it's a bit different. And here's like a visual view of what this looks like, right? We have the pipelines, like I mentioned. It has activities, and there's data set definitions in Azure at least. And there's linked services and integration runtimes. And then triggers and templates kind of sit outside of the pipeline themselves, because you may use a template or you may have a trigger a pipeline, but they're not part of the pipeline itself. So as I mentioned earlier, there's no such direct concept as a data set, though you do reference semantic models. Thanks, Jeff, for that question. And linked services are as I said, they're called connections, and integration runtimes are known as gateways. So just wanted to touch on that here. Forgot that I had two separate slides. I probably should just had one here. All right, so Data Factory components. I think of the Data Factory itself, as I mentioned, it's basically the shell that catches everything. It's your environmental boundary, and that basically it's a good way to structure your security around this environmental boundary. So you're going to have a separate environment, a separate Data Factory per environment. If you have a larger production workload environment, your QA environment, your dev environment, you may have a UAT environment. So you're going to have different Data Factories, one per environment. Is the approach that you're going to have. How did this slide just change back? I did not touch a thing. All right, so back to the slide. You have, as I mentioned, in the Data Factory, you have all your components in there, your pipelines and so forth. But the key here, I think what's important is it's per environment, and it is a security boundary where you can have different security levels and access controls. In a very large environment, You may have a completely different organization. At PwC, we have a completely separate organization that handles our stage and production environments. We, in research and development or in the application technology teams, do not have the ability ever to touch production. It's off limits. It's literally a completely different organization that manages it, and we have to give them all the guidelines and run books of how to do that. So the key here again is each data factory is a separate environment. Now in Fabric, there's a concept of workspaces. For those of you that have worked with Power BI, you're familiar with workspaces in Power BI. It's the same concept. So you're going to have a data factory per workspace. You can have a data factory defined inside of a workspace, and that's your boundary for your environment from a security point of view inside of a workspace. That's, where you're going to grant what can happen or take place inside of that data factory. It's important to know that Data Factory can integrate with Git and with Azure DevOps. So for source control, you can check your Data Factory components and that you've created into source control for proper, code retention and promotion and so forth, and change control. And you can also commit some of the components into source control inside of Fabric. It's evolving, but it's not 100% coverage inside of Fabric yet. So it's something to keep in mind. And then you can deploy Data Factory in Azure as what's known as an ARM template, which is an Azure Resource Manager template. So when you are ready to promote your code from a lower environment to a higher environment, you don't integrate your production environment with your source control directly. You take your Data Factory and you publish it out. And that creates basically an ARM template, which is something that you can use in Azure to deploy components or services rather. And part of those services being your Data Factory components that you're going to go ahead and deploy into the cloud into a different environment. In Fabric, you're going to deploy them with a deployment pipeline, which exists inside of Fabric, and you can promote your code that way. So looking at the pipelines, I mentioned that, then we'll probably skip through some of these slides a little bit quicker because I really addressed them in a little bit more detail than I probably should have in the overview. But basically, the pipelines define your workflow, right? They're similar to an SSIS package. We haven't talked about that yet. So for those of you who have used SQL Server integration services and the packages, your pipeline is similar or akin to a package. There is a Canvas designer, which you'll see that you can use in the user interface. And then you have your activities inside of that pipeline. The activities, like I mentioned, the primary purpose is to move and transform data, right? You can have different types of activities too, though. You can have iterational and conditional activities that we'll see. You can loop through the data if you'd like, and you can have multiple activities run on that source data in a more complex scenario. You can also trigger, as I mentioned, a data flow. You can also trigger a Databricks or a Spark notebook. You can trigger Azure ML workloads. You can trigger Azure functions. So there's a lot that you can do from Data Factory activities. And data flows, like I mentioned, again, they run on Spark, also Synapse and Databricks environments. So that's the key thing to remember with data flows, is that they're a no-code, low-code implementation of taking your, instead of having to manually code inside of Python or inside of something known as PySpark, your notebooks that actually run inside of the Spark workloads, you can do so graphically, and you can run those through data flows. And again, you can execute them from a Data Factory pipeline, but there's other ways you can execute them as well. So data sets, again, are just an ADF construct, Azure Data Factory construct. They define and basically reference your schema for input and output. You do have that construct known as a semantic model inside of Fabric. I think for clarity, I'll add a slide or two on that and the differences thereof. Just know that in the case of a data set in Data Factory, it's just a schema representation. But a semantic model inside what used to be called a data set in Power BI is not just a schema. It basically is used in more than just that way, because if you import data into that semantic model, it's actually storing your data as well. And that would be like for an import type of semantic model. And then we talked about linked services and connections. But what we didn't talk about yet is the key difference in how many more ADF has than Data Factory and Fabric has. You can see there's at least as of, I think 3 or 4 weeks ago when I presented this last, there's 114 supported connectors. I don't know why I have 90 in here. I think there was a reason that I had these separate and now I don't recall. I think there's 114 total, but 90 are supported natively by Microsoft. I need to fix this slide. I apologize. But there's 40 from Microsoft. But what's important to know is that the Fabric, the 40 that are supported by Microsoft in Fabric, 13 are source only. So meaning you can't write back to those 13. You can only write back to 27 of them. Those can be your destinations or what's known as a sink. And we talked about integration runtimes. There are 3 types, though, that I want to call out. There's Azure hosted runtimes inside of ADF. They're known as Fabric capacities inside, or rather your integration runtime, if you will, is basically your Fabric capacity. And then you have a self-hosted model, which you can run inside of virtual machines inside of your virtual network, or you can run them even through a VPN or even without a VPN on-premise at your location. In Fabric, those are on-premise and virtual network gateways. There's 2 types of gateways that you can use. And then in ADF only, there is something known as SQL Server Integration Service runtimes, where you can run your SSIS packages, your legacy packages inside of ADF. So we talked about triggers and schedules. There's different types that you can run either in a recurring schedule. You can run them, at intervals. You can make them event-based, based on events that happen inside Azure, or just trigger them through API calls as well. Inside of ADF, there's something called a tumbling window trigger, which allows you to chain multiple triggers together. So what would happen there is, let's say you have 3 different pipelines that you want to run, but you don't want to run the second until the first one succeeds, and you don't want to run the third until the second one succeeds. Those are called tumbling windows. So you could actually go ahead and set up a tumbling window series of triggers for your pipelines. There's storage event triggers. So this is important for picking up new files that might get deposited into an Azure Blob Storage account or an ADLS Gen 2 account. You can actually trigger your pipelines from those types of events. And you can also trigger in ADF off of something known as Azure Event Grid. So if there's events that are coming through Event Grid, you can trigger pipelines to run after those events are raised. And we talked about the templates you can create from your own, or you can sample from Microsoft, one of their templates, to go ahead and create, your data factory. So with that, I'd like to stop and sip some water. If you have any questions, feel free to pop them up here or unmute your mic. I'm happy to take them. No questions? Okay. We should offer like free beer and drinks or something, Cecilia, and then we'll have virtual drinks. All right, so yeah. So let's do a demo on Azure Data Factory real quick. So let me go ahead and change over. So let's see where I have my Windows open. Let me just jump over to the correct tab. So here we have the main user interface for Azure Data Factory. I've created a factory here called ADF Demo Factory, and I have a script that creates the factory dynamically with a random code. That's what you're looking at right there. So you can just disregard that. Your data factories have to be uniquely named inside your estate. So in an interest of being unique, that's why I picked that. So let's take a look at this interface. So we have pipelines. We have a new preview feature here called Change Data Capture, which Microsoft has recently added. We have the concept of data sets that I talked about before, and data flows, which I mentioned. There's also something known as Power Query. Similar to Power BI, you can run Power Query statements from here. Probably should add that to the slide deck. So this is your authoring mode inside of Data Factory. You have a monitoring mode or screen where you can basically see any executions that you had for your pipelines, any triggers that triggered your pipelines. You can also see activity inside your integration runtimes and any data flows that ran and any alerts that were triggered for those executions. Looks like we have a question. Alex is asking, if we know the procedure on how to create a data factory connection or link with Fabric Data Lake. Are you saying Fabric One Lake, I believe is the question? And I can answer that even though I've never done that. One Lake works off of the same ADLS interface. So you can address One Lake as if it was a single, very large ADLS storage account. So my expectation would be that we should be able to point to One Lake using that. Now, as far as what the procedure is, my expectation would be that Data Factory would have to be authorized to access One Lake either by adding a storage account here and using either a probably like a managed identity on the integration runtime. So let's take that offline, Alex. That's a very good question, and I'm happy to look at that a little bit later at the end of the presentation. There is a manage section here where you can look at your general settings. You can also look at and define your linked services that we talked about earlier. You have your integration runtimes and so forth. Let me just take a quick view through what we have here. So under linked services, you'll see that I have two linked services. I have a source database and I have a destination database. Both of these are Azure SQL databases, and those are going to get used and referenced inside of the pipelines. And you'll see if you under here, these are the references to these linked services, so you don't accidentally delete something that is currently in use. So if we take a look, for example, at the reference for the destination database, there are 3 references. There's a data set that references it, which is the sales order destination data set, and there are 2 pipelines that are pointing to the destination database. And similarly, if we take a look at the source, you'll notice that there's a source data set that's referenced to the source right now. Integration runtimes, you can have your own integration runtimes that you create in here that are known as self-hosted integration runtimes, as well as the SSIS runtimes. But by default, you have a Azure hosted runtime, and you see that it's called auto-resolving integration runtime. The difference here between auto-resolving and something that's not auto-resolving is that if we click on new, you'll notice that we have an Azure, or this should say Azure or self-hosted, because this is basically one type of runtime, and an SSIS runtime is completely distinct. But this is a little bit misleading because it could be self-hosted or it could be hosted in Azure. So we'll just keep the default selection and we'll hit continue. And you'll see here that we have now those 2 options to do an Azure hosted integration runtime or a self-hosted integration runtime. So in self-hosted would be something that you, again, would install on a virtual machine in the cloud or on-premise in your office. But we'll pick Azure for right now and we'll hit continue. And you'll notice that I can give it whatever name I want. give it a description if I want. If there's a virtual network that I want it to be able to reach into inside of my Azure environment, I can establish that here as well. And then the region, you'll see by default is auto resolve. And that's actually what the auto resolve integration runtime is that's already created. So it'd be kind of pointless for me to create another auto resolving runtime unless I intentionally want to, for monitoring purposes, separate activities and pipelines that run for one set of pipelines to see them under one integration runtime versus another. It's, again, otherwise pointless to create another auto-resolving runtime. But why would you create another Azure-hosted, not self-hosted integration runtime? For you to explicitly pick a region that you want it to run in. Because by default, an auto-resolving runtime will determine where it should run the entire pipeline, and the activities in that pipeline will basically, you can select different runtimes from within your actual factory, your pipeline activities, but by leaving it at auto resolve, it'll determine the best location to run it. So let's say that your source for your data is in one Azure region, and your destination for that activity is in that pipeline is in another region. It's going to have to pick one location to pull that data from and extract it and save it into that other destination. And it's going to select whichever one it feels is going to be the most performant, unless you actively select an explicit region by creating a different runtime. So in some cases, Azure may not make the right call, and you may want to have manually defined integration runtimes that you select for your activities and have it, run in an explicit region no matter what. So I just wanted to bring that to everyone's attention. We're not going to dive any further into that, but just wanted that to be aware. Jeff, do you have a question?
Well, I was just going to comment on that. I always select the region, and I always make sure that it's like in the same region the rest of my data is. Otherwise, you will pay more to move your data in and out of other regions.
That's a good point.
Regions. So always make sure all of your resources that you're touching are in that same region that the data factory is in, and make sure the runtime is in that data factory. Or if you have to split them up, create a runtime in that zone, create the runtime in the other. That way you only transfer what minimal data you need to. Otherwise, you're going to be paying more.
That's very good advice. While you're learning, if you're working on small workloads, it probably is a little less critical. But Jeff makes a great point for moving large volumes of data. You definitely want to, explicitly pick that. Purview is a Microsoft governance tool that allows you to basically define define and catalog your entire data estate. It's more of like a scheme, a big table of contents and/or index to all of your data across your entire enterprise, and what's there and what fields there are and what categorizations there are for those fields of data. So you can very quickly identify where you might have personally identifiable information and sensitive information. You can connect Data Factory to it to basically discover additional sources of data that you may have access to. Source control, we talked about earlier. You can configure source control for Data Factory to take your changes and actually integrate them with Git. We won't go into all that today, but you can do that. And you can import an ARM template from a previous export that you may have saved in a different Data Factory. So you can manually import it here if you don't use CI/CD pipelines, or if you want to restore your Data Factory that you were working on, a few months ago, and you're at your home environment or your dev box or whatever, you want to re-import your template, you could do that. You can also export the Data Factory as an ARM template, which is also accomplished through something known as a publish procedure. You can see up here, there's a publish all option, which essentially does the same thing. It packages up your Data Factory as an ARM template, and it ends up basically in a zip file. Triggers, we talked about earlier. You can create the different triggers here. You can do a scheduled trigger, a tumbling window trigger. You can respond to storage events or custom events that exist inside of an event grid, which we talked about as well. So that capability is in here. And global parameters are parameters you can define that will basically be used across all your pipelines, and you can set those parameters here to then be overridden per environment. So let's say that you have parameters that you, different values that you need to pass into your pipelines for different environments, because you have different servers in your dev environment than you do your production environment, right? So how do you parameterize what is your dev server for the source and your dev server for your destination of data versus the production source and destination? So you can define parameters in here. These parameters become parameters in that ARM template that we talked about when you publish and export your data factory. These parameters can then be parameterized when you're deploying your data factory to your higher environment, like your production environment, and pass in those server names as an example. So that's what the global parameters are. Data flow libraries just allow you to basically have a set of functions that you can use inside of your data flows that you can then reference. Think of it as like a little code repository where you can basically have your various functions defined and saved. And then there's credentials that you can establish that you can reuse across your linked services, so you don't have to keep manually defining them across different linked services. You can reference to the same credential or credentials from here. And a customer managed key is basically used for encrypting your data factory using your own key. By default, it's encrypted by Microsoft's key, but you can specify your own managed key for encrypting your entire data factory definition. And outbound rules I've never used. Let's discover what it is here, because apparently it's a new feature. Enables the outbound rule policy that allows you to restrict outbound endpoints as specified in the Azure policy. So Azure policy is a technology feature inside of Azure that Microsoft has that allows you to have governance over your entire Azure tenant or specific subscriptions inside of your Azure tenant. And you can define things that can and cannot happen inside of your various Azure services. So here, this basically says that it impacts outbound calls to data sources from the pipeline activities and includes including the authoring scenarios. It can be used to allow select or admin certified data sources within Data Factory and may prevent data exfiltration, which is basically your data leaving your company or your organization's control and being basically pushed out of your company or your organization to data sources or destinations that you do not permit. So that's what this functionality I gather is basically doing. It's basically going to allow you to use Azure policy to dictate what you can and cannot point to as a data source or a destination. The publish here, just as you can see, flagged because I made a change and now it thinks there's a change and it wants me to publish the changes. But if you can just ignore that for just a second, let me refresh this and have it ignore what just took place. And there's a learning center, so you can come in here and learn some quick starts and tutorials and reference the documentation for Data Factory. So let's take a look really quickly here at this. The way it builds up, actually, let me come back into managed services and let's look at the linked services. So if we look at the source database, you'll see that I'm pointing to this particular source server, and I have a source database named source database. I'm using SQL authentication, although I could have used a managed identity or a service principal, which provides for not having to specify credentials like passwords inside of your data sources, which is highly recommended for this demo. It is a password-driven demo. You can also reference a key vault for your password, so you're not storing your password inside of Data Factory, but you're storing it in an encrypted and more secure key vault. And you can reference that for your data sources and destinations as well. And basically you can, here, I'll just click here at the bottom. We can test our connection real quick and make sure that it was successful and that we were able to establish that connectivity. And just for safety's sake, I'm going to test the connection on the destination database as well, and that connected successfully as well. So now let's go back into our author mode, and we have pipelines, and there's 3 of them here, but I do want to just start by looking at the data sets. So the data sets are required to point to any source or destination data source and reference either a table or you'd have different, basically, you may reference a file that's coming through a data set so that you can define what schema might be coming in through a CSV file. But in these particular cases, we have the source and the destination, which it's aware of what type of source and destination it is. It's an Azure SQL database. And we are referencing the linked service that I have defined for that source database and a specific table name inside that database. So we're going from the sales.orders table, and we can preview the data there that's in that table real quick. And we'll see that we have an order ID, customer ID, some information about the salesperson, order date, etc. Right? And this is just returning the top, 10 rows of data here that we have. So we know that we're able to establish the connection. We could have tested it here as well. And we are able to preview the data. So we know that we're able to pull the data. We have access to that table, etc. We have a way to view the schema of that table, which has already been imported here as part of this, this setup. And if we had any parameters to the data set, we could add them here. What the parameters do is allow you to specify a different table name. This is a more complex use case, but it's a common use case, is that why should we create a data set for every single source table at a data source, for example, that we want to query and have to deal with the schema on every single one of them? Maybe we just want one data set that rules them all because it's an Azure SQL database that we're going against and we need to pull multiple tables. We could parameterize this table setting here by basically choosing this enter manually option and referencing a parameter that we defined in here. And there could be 2 parameters. There could be a schema and there could be a table name, and we could put both of those parameters here into that field if we entered it manually. So just keep in mind that there is a way to parameterize these so you're not having to create a separate data set for every single source or destination table. The destination is an example, actually, of the parameters. I should have just come in here and showed you. Here's those 2 parameters that I just mentioned. So I'm going to have a schema and I'm going to have a table parameter, and I'm going to not import the schema because there could be different destination tables that I want to reference or source tables, right? And here we can just basically reference that data set schema and table parameter. And it's inside of Data Factory, when you use the @, you are saying, I want to reference something that's dynamic. And then you oftentimes refer to the object similar, like you see here. It's like almost like a function call with parentheses, because in some cases you can pass a parameter into it, but most of the time you don't. Just be aware of that. All right, so in this example, there is no Power Query or data flows, but let's take a look at these different pipelines. So we have a copy sales orders pipeline. So this is a simple pipeline with a simple activity. It's a copy data activity. And you'll notice you can specify some information about it. If you want it to retry after failure, how many times do you want it to retry? How long in seconds do you want it to wait before retries? How long do you want this entire activity to possibly execute before completely timing out? This is the default value, which is a very, very long time. That's, I think it's actually days. I think it's 7 days that it could potentially run for an entire week. So always change that setting. Don't just keep it at the default. That could render a pipeline stuck for up to a week, and you don't want that. So here you can specify a source and a sink, source and the destination. They call it a sink. And so the source data set is going to be my source data set that we looked at previously. And we're going to either reference a table directly, or you could specify a SQL query, or you can call a stored procedure to extract the data. And again, we have now a timeout for the actual query. So this is the general timeout here on the general tab for the entire activity, but this is basically your query timeout, how long it could run for before it completes extracting or selecting the data once it finally connects. And then your isolation level. So if by default in SQL Server, it will be read committed, but you may want to use snapshot isolation to extract your data and not take locks that might be blocking on your workload. So you can actually select that here as well. Although actually in Azure SQL Database, I take that back. Azure SQL Database by default is read committed snapshot isolation, I believe, as the isolation level. So in Azure SQL Database, we are taking advantage of snapshot isolation. So again, you could preview the data here if you want. We'll do that just to confirm we're good. And then we have a sink, and the sink is basically our destination. And we have the sales schema and the orders table that we want to insert into. We could do an upsert behavior, which will basically insert if it's missing or update the row if it exists, but you need to make sure that your primary keys match. And you could also do a bulk insert operation to speed up the process if you'd like, and just some other timeouts and batch sizes of how many rows you want to insert into SQL per batch so that it can do some more efficiently. By default, it determines the appropriate batch size based on the row size. So we'll leave that empty. Mapping is the mapping of the source to the destination columns. So here's where you could change what column the source to the destination is basically going to. Since our destination is already defined, it's not, it's defined to have the same data type and everything. So we're not changing anything here really. This is just for observational purposes. There are some settings here as well. Each of the activities have different settings, so just be aware of that there are different parameters that you can change. User properties, you'll see this tab on almost everything in Data Factory. This is a way for you to tag different objects inside of Data Factory that you want to then show up in the activity log, or that you want to use to find objects inside of Data Factory. So this is basically just your way to annotate different activities or pipelines that might be related, or that you want to be able to, like I said, search for inside of the log. And that's basically it. So when you are done creating your pipeline, which this is, again, a very simple pipeline, we'll look at a little more complex example next, but basically you will validate your pipeline. And if there were any errors with your settings, or a syntax error that you may have had, or you missed a field that's required, those would appear here, and it'll be an entire list of validation failures that you would have. And then you can basically debug execute this pipeline, which allows you to interactively see the activity as it's happening here in the user interface. Or you can trigger this to run at a later date and time by creating a trigger, which from here basically adds a trigger definition back in that other screen that we looked at earlier, which allows you to define and list out all your triggers. Or you can reference an existing trigger that you have already defined so that this runs with an existing trigger, or you can trigger it to run now. So what is the difference between triggering it to run now or clicking on debug? And again, debug is allowing you to see it interactively in front of you. If we simply did a trigger now, we would have to come back over here to the left-hand side of the screen, go into the monitor section, find this particular pipeline that's executing and this instance of the pipeline, because there could be multiple instances of the same pipeline executing. and then look at the activity from there. So debug is just a nice way for us to see it right here interactively. And I would encourage you when you're debugging to initially to do that. And I mentioned earlier, just a second ago, that the same pipeline can run more than once. Notice that if you click off of the activity here, Jeff, you have a question or comment?
No, just a comment. The triggering also only executes the published version versus debugging will only trigger what you have done in dev if you have source control set up.
That is a fair statement. So if to clarify further, if you have this data factory enabled with source control with Git, it works a little bit differently, where if you actually make changes in here, you have to publish those changes in order for them to actually run in the factory in that basically production environment. Otherwise, you're just running them separate from the production from that runtime, and you're getting your own runtime, and you're running them separately from that. So a debug will run it in the runtime that is decoupled from your published environment. Just something to keep in mind. If you click off of the activity onto the actual canvas of a pipeline, you can define parameters for the pipeline that you can then pass through your triggers or through API triggers that you use to call your pipeline. You can define variables that can get used and reused throughout your workflow. But also you have a set of settings, and one of those settings is the concurrency, which allows you to limit how many simultaneous pipeline runs can be fired for this pipeline. So if you wanted to ensure that only one of this pipeline can ever run at any given time, you could put a value of 1 in here, and that will ensure that no one else can run the same pipeline simultaneously. And so any queued requests to run it would basically get queued up, and run one at a time. So let's go ahead and actually execute this, and we'll run it. And you'll notice that this basically debug output screen shows up, and we have our pipeline is queued. And in a few more seconds, it will actually start. Sometimes you need to refresh this. It tends to refresh on its own, but sometimes you got to kick it. See, I had to click refresh because we were going to wait another 20 seconds for it to be complete, to update itself. All right, so it succeeded, right? I do want to point out that whenever you have an activity, there's an input to an activity, which is most of the time the instructions and parameters for that activity to execute. Sometimes it's values, like if you're passing in parameters into that activity. And so if we click on that input, you'll see that these are the configurations for this copy activity: the source, the sink or the destination. Then here are all your translations for your column mappings, right? Let me scroll all the way down past all the other column mappings. And then I think that's all that this particular activity has. I thought there was something else. So there's not much to that one. But if we look at the output, you can see information about what happened as part of that activity. How much data was read, how much was written in terms of bytes, how many peak connections there were to the destination. There was one connection to the source database and 2 connections writing to the destination. How many rows were read and how many rows were successfully copied. The duration in seconds, and the throughput of that copy. So basically 326, I believe it's, I think it's 326. I think this is per minute, and it's how many megabits per second. Sorry, megabits per second, I think, actually. I don't think it's per minute. I forget what it actually equates to be blunt. You'll notice here that you have the integration runtime that it was run on. So it auto-resolved to East US 2. And there's also a billing event. So of course, Microsoft wants your money. And so here we can see some information about the actual activity, the duration of that billable duration, and what that might actually equate to in terms of the actual billable event. So you can see the fraction of an hour of a data integration unit hour, or DIU hour. And you can see here some additional details, just basically a repeat of some of the information that we had as the input. And let me just see, I think that's pretty much it. Yep, this was if there was a queue. So if this particular activity had to wait for other activities to complete in the runtime, maybe run by other pipelines, it would have indicated how long it had to wait. So, so that's basically it. You can then click here and look at the details of the copy activity, which is pretty nice looking, nice graphical representation of some of this information that we looked at. And it's a useful way to kind of get an eyes on the activities that actually took place. You'll notice that the copy activity was a fraction of a DIU hour. However, this particular total execution took 4 DIUs total for the billable event. Why is that? The reason is because you get charged for the time of the pipeline execution. You get charged for the actual compute that was used to perform the operations and the activities. And you also get charged for the actual throughput of data that took place, and it is kilobytes per second. So 326 kilobytes per second on the throughput. So keep in mind that Data Factory is going to charge you for different aspects to your, it's not just a simple, hey, how much data am I copying? It's actually how long these activities had to run are also going to affect your billable amount. It would be nice if they put the dollar amount here. You have to obviously go calculate that out with their pricing sheet information, but just wanted to share that here. You'll notice that we were in a queue for 8 seconds total to run this this entire activity. And the pre-copy script, if there was something that would have run, it would have tagged it here. We did not have a pre-copy script. The transfer itself took 16 total seconds. All right, so with that, let's go back into my portal here in the Azure portal, and let's take a look really quick at what we have. So I have a resource group here for the demo, and we have the Data Factory that we are currently working with here. That's our Data Factory. And then we have 2 SQL servers, the destination and the source that we've been studying. There's also a blob storage account, which was used to create the source database, the sample database, which I downloaded it basically from Microsoft to create. And we have the source and the destination databases here. So let's take a real quick look at the source. And we'll look through a query editor real quick here. And let's take a look at the tables that are here. So basically, we have a sales orders table here, and this is the table that we're actually, copying over. So let's just do a select count from sales orders, and I will copy this over so we can run it on our destination. Obviously, we already copied over that table, so should have probably run this beforehand, but let me go take a look at the destination database real quick. And let's study this one. This basically has just that one table that we copied over. And if we query this one, I should probably run this here. We get the same amount. We have the same number of rows. Let's query the top 10 rows from here, and you'll see our data here. So that copied over. So now let's take a look at a little bit more complex use case inside of the pipelines. That was just copying over all the data, right? But what if the data is changing? There is a way to copy over changing data using change data capture, but you may have a more complex use case, or you may have a specific need. You may have multiple activities that you want to chain together. So you have a delta, I'm calling it a delta sync pipeline. So you can do a delta sync with what's known as basically by looking up the max order ID, which would only basically take the most recently inserted order into the table, and it would actually go ahead and just copy over that particular order. Or we can do it by date. We'll study the date one here in just a second, but let's take a look at this one real quick. So here we're chaining multiple activities, and you can see that we can basically have two activities feeding into a subsequent activity. So in a nutshell, this is basically allowing us to chain one query or one lookup and another lookup here and feed them both into the copy activity. And then ultimately we call a stored procedure here to update a watermark. So that doesn't necessarily, here, let me just go ahead and actually show you here. We have an update watermark stored procedure in here, which is something that I believe I need to still create. I don't think I have that in my destination database, so I will go ahead and create that separately. But let's take a look at this. So we do a lookup watermark query. So what this is doing is basically selecting a watermark value from a watermark table. And that value is basically just a high watermark that we're storing in a single row inside of that table. And then here we're looking at the lookup max order ID, which is basically taking the max order ID from the sales orders table, returning that first row. You don't really have to do a select top one, but it does short some of that overhead out. Basically takes that maximum value of that order ID and pulls it out. And then the copy data activity is going to now run a query instead of an entire table. And what it's basically doing is it's selecting from the sales orders table where the order ID is greater than the output from our lookup watermark saved value. So our previously saved value for a high watermark, if the value is greater, then it knows that it's going to go ahead and obviously pull data that is for a greater or newer order ID. And then ultimately here, we're going to update the watermark using the value here by basically taking the max order ID that we now had inside of our lookup max order ID query that ran earlier. So that's how you can tie together, and you'll notice that there's different types of connectors that you can have from one activity to the next. This particular on success connector is probably the one that you would use the most. You can have on error or on failure connectors as well to do something if something fails. You can also have a connector that will run either way. So whether this current activity succeeds or fails, I want to now continue on and do something else. And again, if you feed more than one activity into an activity like there is here, this copy data step will wait for both lookups to complete before it runs the copy data activity. So you can chain these and orchestrate them however you like. All right, so let's take a look at the Delta Sync by date pipeline here. So this here is a little bit more involved. It's very similar to before as far as looking up a watermark. So nothing changes here as far as our watermark value from our watermark table. And this value, by the way, we're storing on the destination database. So we need to create this watermark table in just a second, and we'll do that together in order to run this. But you'll see here we have a lookup edited orders. So instead of just getting the high watermark of the orders, the max order ID, let's instead get the last edited when value from a particular order, so that if an order changes, it'll be included in those changes, right? It's not just going to be new orders that are coming in. And so what I have here is basically a staging table that I used as part of, I think, the copy activity. So let me just take a look here. You can just see how we're chaining this together. Let me just make sure that yeah, so here, the way this is working is I have a staging table. So in the destination, we would create a staging schema and a sales orders table. Because remember in our ETL diagram that we had in the presentation deck, you may have staging tables that you want to put your data into. So that's one pattern that you could go ahead and use, is basically have a staging table that you're going to go ahead and insert your rows into. And if you drop that staging table, then all you have to concern yourself with, if you're the only pipeline that's running, is basically to insert all the new rows into that staging table. And then you could call a merge procedure, a stored procedure that would basically perform a merge. And that stored procedure would have basically a merge statement in it. Or you could do an upsert, like we mentioned earlier, you could do an upsert on the rows and not have to call a stored procedure. But I'm calling a stored procedure just to give an example here of what you could do, because maybe there's some manual steps you want to do inside the stored procedure or handle the merge differently. And then you update the watermark. And I think we have a question, so let me jump up. We have a question from Polly. What's the best way to send an email from ADF, for example, on failure of an activity? It's a great question. So I've done calls into Azure Functions, where the Azure function basically is tied to an email service. So if you have an Azure function, that's one way to do it. Another way would be, let me think here. Let's see here. You could do a web hook or a web call that you might have somewhere through an API that you can use to go ahead and send that email. That would be another way that you could execute that. You could use, if you have on one of your databases, if you have database mail set up in SQL, if it was a traditional SQL server instead of Azure SQL, you could probably call a stored procedure that has access to send mail through DB mail inside of SQL. Those are the couple ways that I could think of to actually send that. But an Azure function would probably be my preferred way. That again could be tied to a particular email service. So one thing that Azure does, which I don't care for, is Azure restricts our ability to run our own email server by default. Like, you have to jump through hoops to get Microsoft to allow you to run your own email server. They obviously want you to run Exchange Server through Office 365. So that would be one way to make a call into Exchange. But the other reason is because they obviously don't want to be a source for spam. So a lot of workloads that I've worked with often will use a third-party service or an internal email server. One of those services is SendGrid, and so you can make an API call to SendGrid. Jeff, go ahead.
So another option for failed activity to set up alerts. You can set up alerts.
Yes.
They're not really the best, but you can at least get a notification that something is wrong and go and look at it. I really don't like them, and I don't like it. There's no way to really email smoothly from this, but the way I set up rules is I turn it on and immediately turn it off. So I get like one notification if there's a failure and shut it off, so I don't like getting notified. Otherwise, it'll notify you consistently, constantly.
So you're suggesting if you come in here and you set up an email notification from here, I guess you'd have to set up an action group. This sets up an action group in Azure Monitor, I guess.
Yeah, it sets up an action group, and then I add, normally a couple of email addresses to it, so or a group to it, so we all get notified. And then I select the criteria based on whether a pipeline has failed, and send an alert that way.
So these are the different criterias for, so Polly, it's going to be just notifying you if basically a pipeline, fails gets canceled, etc. Failed activity or metrics, things like that. I would say it depends. Like if you want to send a failure, if you want to send an email just for one explicit activity that failed, then you'd have to use all the approaches that I mentioned. But if you want to get emails for every single failure, you could do it the way it's set up here that Jeff mentioned. All right. I think for the interest of time, I think that we'll probably skip going through all the other executing these pipelines at this point because we have to talk about Fabric. So let's do that. Let me come back into my slide deck, and I'm losing my voice. I was on calls all day today. All right, Data Factory pricing. So I mentioned earlier that you're charged for different things. Jeff, do you still have something? Or your hands up? No? Okay.
No, sorry, I just put it down.
No worries. So prices vary based on whether you're using an Azure hosted or a self-hosted runtime. It's cheaper to move data in your own self-hosted runtime than to have Microsoft run it inside of their compute. Your orchestration is charged per 1,000 runs. So basically, those are your pipeline runs, and there's a charge per 1,000 runs. That's the billable unit. There's execution charges, as I mentioned earlier, by certain activities per hour. So how long that particular activity runs. So the copy activity ran for 8 seconds. You're going to get charged 8 seconds of 1 hour's worth of charge for that particular copy activity. And then you're going to, if you use data flows, get charged per vCore hour, which is a virtual compute core or a virtual CPU core hour charge. And depending upon how many cores you're allowing your data flow to use and how many cores were used by those activities in your data flow. And then data factory operations. So you read, you write, data, like I mentioned earlier, you will be charged for those as well. So, and data factory and Fabric. So let's take a look at data factory in Fabric. Cecilia's happy now. So
I'm always happy.
You're always happy.
One question though, I'm not
Yeah.
sure if you saw the question in the chat. It's been a while, but I don't know if you saw it.
Which one?
Can you run legacy ETL through ADF? Yeah,
so I can only have QA or chat open, so I had QA open. I'm sorry, I didn't see that. Can you run legacy ETLs through ADF? By legacy ETLs, are we referring to SSIS packages, which we talked about earlier? If so, yes. You can run, and let me just come back here real quick. If you create a new pipeline, and you basically come here through, you have, I think it's under, I'm not sure it's under general. Yeah, it is. There it is, execute SSIS package. So you could, if is this what you're referring to, Raphael, is a legacy SSIS package pipeline? Do you mind clarifying? You're welcome to take your mic off mute or type it in the chat. But anyway, if that is correct, you can run it here by specifying your SSIS package. Just be aware that you need to specify a SSIS integration runtime. So earlier I was showing notice that I don't have any SSIS integration runtimes. That's because you would have to come into the manage screen, create a new SSIS integration runtime, and then that SSIS integration runtime would be available to you to execute that legacy package. Hopefully that answered your question.
You have another one in the Q&A from Ed.
It doesn't light up on my end, so I didn't even know there was anything on the other tab. All right, let me go to the other tab. All right. What type or size of company would be a best candidate for MS Fabric Data Factory, knowing there are limitations in using Azure Data Factory? SaaS will give us more granular control. So that's a great question. what size of company. I don't think it matters what size. So there could be a use case for a small startup with only 2 or 3 folks, that there's some data connector inside of Data Factory that is needed as a linked service that's not available in the Fabric Data Factory. And it just makes sense to use Azure Data Factory for that. I don't think it's necessarily company size. However, I will say this, there's no reason for you to implement and pay for Fabric to accomplish something that's very specific and potentially, use case specific that you don't need Fabric for. So one thing to keep in mind with Fabric is anything we do in Fabric needs to run on a Fabric capacity, formerly known as a Power BI capacity. And Fabric capacities can get expensive. You can pause Fabric capacities when you're not using them, but to implement the Fabric tenant and get yourself a Fabric capacity and then use Fabric Data Factory, unless you're making use of the other features in Fabric, like the Lakehouse features or something else inside of Fabric, there's probably less of a use case there. So I think it's use case specific. So one thing I want to point out here, you'll notice that we're at the home of app.fabric.com, and you'll notice it says Experience Power BI. So let's see if we take that experience off of here and we look at the home here without Fabric. Oh, sorry, without Power BI. And all of a sudden our icon changed to the Fabric icon, and it says that it's Microsoft Fabric, and we're still in a very similar screen. So something that I like to show folks who don't believe us is if we come here into a command prompt, and I'll make this larger, just give me a second. All right, if we come in here and we do a lookup on app.fabric.microsoft.com, you'll notice that one of the aliases for it is app.powerbi. So we're actually basically connecting to the same endpoint that Microsoft has for Power BI. And for good reason, as I mentioned earlier, Fabric was built on the Power BI operationalization like management plane, and the concepts in Fabric of workspaces and capacities are all the same as Power BI, but it's not Power BI. Just keep in mind that they're using the same management system and organizational, backplane, management plane, but it's not the same. And the reason it's not the same is if you take a Power BI capacity that's used to run your Power BI reports, it can only run your Power BI reports, and Microsoft is deprecating Power BI capacities, premium capacities, very soon. Within, I think it's at some point in 2025 that it's being deprecated, and you will only be able to purchase Fabric capacities even to run your Power BI reports. But today, if you have a Power BI capacity, you cannot run Fabric workloads on it. You have to purchase a Fabric capacity, which runs all types of Fabric activities, including Power BI report rendering. So just keep that in mind. All right, so Fabric. Different things you can do in Fabric. This is basically, home plate starting here with Fabric. If you click on the Fabric logo down here, you have different personas. You may want to work with Power BI. You may want to work with Data Factory or some of these other Synapse workloads, or you may just want to go, directly into any one of them. But let's just really quickly touch on here at the gears at the top right. You'll notice that there's an admin portal here, and I'll click on this real quick. This looks very similar to the Power BI admin portal with tenant settings and different, configurations for your workspaces and your metrics and your users and so forth, right? And even premium per user, which is a Power BI construct. It's not really a Fabric construct. So they basically blended Power BI with Fabric. If you already have Power BI and you enable Fabric, you are basically, for all intents and purposes, upgrading your tenant, your Power BI tenant, to Fabric, and you will have all these additional settings, whether or not you use them. And so you can see that there's some settings in here that are going to be related to Power BI, like I said earlier, but others are going to be related specifically to Fabric. So let me just, you'll notice that all these additional things appeared here all of a sudden for me on the left when I got into this screen. Many of these appear when you go into those different personas. We're right now in the Power BI persona, and isn't it kind of interesting? I say it again, it's Power BI. When we were on that home screen and we went into the admin portal, what persona did it pick? It picked Power BI persona. So that's kind of interesting to me. So you do have the concept of workspaces just like you do in Power BI because they are the same workspace. If you had Power BI objects in here, they will still be in here. My workspace is the same my workspace that you had in Power BI. It's the same thing. So your workspaces are the same. I have here, you'll notice a Fabric content workspace here that has a little diamond on it. The diamond used to represent a capacity, a premium capacity in Power BI. And it does still in Power BI, but if it's a Fabric enabled workspace, it will say that it's got Fabric content in it. So let's go into this Data Factory revealed demo workspace that I have here. So what just happened? It did not, where's my whole task flow and why did it disappear? Great. Let me see what happened here. This was here an hour ago, 2 hours ago. Let's take a look and see what happened. You'll notice that while we're waiting on this, curiously, we have, so it is linked. Where is my entire task flow? I already had one. All right, so let's take a step back. Let's look at this. So we can basically create items inside of a workspace. In Power BI, you had reports that you can create with your data set. Again, data sets are now called semantic models. So you can see here that we have semantic models. And then you also have a data flow Gen 2, like I mentioned. You can have data flow Gen 2s. Which is basically your data flow type of pipeline, and you have a data pipeline down here. So you'll notice I have this pipeline weather API, which is a data factory in Fabric pipeline. So if we see this little pipeline icon, and again, remember a pipeline is called a data pipeline. So let's go ahead and look inside that data pipeline. And here I have one activity. You'll notice I have a parameter here for a postal code. It's a string. And basically, if I look at this copy activity, which looks similar to our previous data factory pipeline, we have a source and we have a destination. This particular copy data, it is a copy data activity, but my source is a connection that I've established with right now here. Basically, it's a web API type of connection or a web connection that I've established here for this weather stack API. So if I edit this and take a look at it real quick, and by the way, nothing is quick coming back. I would like to look at it this quickly, but you'll notice that things don't run that quick all the time. There's not much I can change about this once I've established it. But you can see that I'm calling this api.weatherstack.com, and it's anonymous authentication because I'm actually specifying the authentication key here inside of the relative URL here. Let's pull this up here. That took a while. All right, let's take a look and see what's happening here. So I'm calling that API endpoint to the current path, and I'm passing in a variable that I have defined inside of this pipeline, this quote factory. I have a variable defined for the API key, which could come from Key Vault or someplace else, but I've manually typed it in for simplicity here. and I'm passing in a couple different additional parameters. I want my weather in Fahrenheit, and I have a parameter that you saw me define at the head of this demo here, where we have a parameter for the postal code, but we didn't provide a value. So when we go to run this, it's going to prompt us for a postal code. So I could go ahead and run this, but I'm not going to run it just yet. I want to go ahead and show you a couple other things first. So I'm a little disappointed at whatever Fabric did to me from an hour ago to now, because I never deleted this, it's called a task flow. So let's not confuse a task flow with a pipeline. Oh, look at this. I refreshed my screen and it's back. Okay. I'm going to call this a night. You all enjoy. If you want to experience Fabric,
yeah, I just
have
had
at
the same
it.
problem with something else.
But if that doesn't
was...
give someone a heart attack, I don't know. Like, I hope you're recording this. You are recording this. Excellent. This is going on a blog. This is going on a blog post. What in the world? Like, you saw that, right? Okay. So, all right. So this is a task flow that I was hoping to explain when I started this demo, not to be confused with a factory pipeline. So this here is a task flow view. You can create a task flow view inside of a workspace when you create a workspace. It has a blank view when you first start. So let me just go create a workspace just real quick to show you this. And we're going to call this, let's just call this demo test. All right. Actually, you know what? We'll call it task flow demo. So I'm going to apply this really quick. And the reason I'm sharing this is because if you really want to think about pipelines in Fabric, there's two types. There's the data pipelines that you can execute, which are basically Fabric, Data Factory and Fabric pipelines, but there's these task flows. And so you can create these through manually adding tasks, or you can select a predefined templated task flow. So you'll notice that there's different types here. And I'm sorry that this isn't larger. I thought I had, maybe this will help you. Okay, I guess my zoom level reset as well. So different types that you can set up. It's not going to create everything for you, but it's going to give you a shell or a template for things that you may want to do in order to accomplish these different types of tasks. What I did was I selected a medallion, task flow. So just to show you how I arrived at this. So if I select this, it will go ahead and create this task flow view for me, but you'll notice that none of these have any items defined in them. There are no items in any of these task steps. So we have to now add items to these different categorizations of our task flow. So what they're showing us here is that, as an example, you may have some high volume data coming in, you may have some low volume data coming in, and you may want to separate those tasks out separately. You will have bronze data that you may want to manipulate, and then you may have some initial processing on that bronze data, like we talked about earlier with the medallion model. You will then end up with data in the silver data tier, and then you may further transform that data into the gold tier or your golden data. And from there, you may go and visualize it inside a Power BI report, or you may call some ML workload as well. All right, so notice they're empty. There's nothing here inside of this view here at the bottom. I have no tasks whatsoever under any one of these categories. They're all empty. So that's just an example. We're going to close this workspace that I created and go back to the one from the demo. So back to our demo workspace, where I do have that task flow, but I have items in that task flow. And you'll notice that I have an item over here in the low volume ingestion space. So we have the Data Factory type of pipeline here. We have the data pipeline that's running to call for the weather that we looked at earlier. So that's going to call that API, get some weather data for us. And then in the bronze data tier is where it's going to get inserted by that data pipeline. And you'll notice that the bronze tier has this lakehouse called Lakehouse Bronze. So in Fabric, you have different types of ways to reference and store your data. You can store it in a lakehouse, or you can store it in a warehouse. And those are two distinct types of workloads. For those of you who have heard of originally Azure SQL Warehouse or Synapse Warehouse, that's what a warehouse is inside of Fabric. A lakehouse inside of Fabric is basically a lake storage location that you store inside of one lake or through a shortcut in one lake. And you basically have Synapse workloads or Spark workloads or Databricks workloads that can access your Parquet stored data, which is what your lakehouse is. And there's a key distinction between what a lakehouse is and a warehouse is in terms of what you use to read and what you use to update your data. You can query your data from a lakehouse using SQL or using a Spark notebook. You can write data into a lakehouse only using Spark notebooks, but you cannot update data in that lakehouse using a different type of compute. However, you can query data out of a lakehouse using a warehouse through a link. It's a little bit more involved, than this demo, but just be aware that there's differences in what you use to read or update your data. In a Fabric warehouse, there is no Spark. You can read data from that warehouse using Spark through a SQL type connector, but you will only update data in the warehouse, typically using SQL notation. So there's key distinct differences. In this demo, I'm only using lakehouses. So we're using workloads that are compatible with a data lake that are either Spark or Dataflow or basically inserting directly into that lakehouse. Okay. So bronze data. So we have the lakehouse. We have a semantic model that defines the schema for that particular lakehouse. And then one thing I want you to be aware of in Fabric is that you have the lakehouse itself, which references your data lake. And you have like I said, the semantic model, but you also have here a SQL Analytics endpoint. So if I go click first on the lakehouse, I just want you to be aware of this distinction because it's a little bit tricky. When you first click into a lakehouse, you have an explorer view and you can explore the tables that are in your lakehouse. And I have this weather data table that matches the schema of the data from that API that we're going to go ahead and call. And for right now, there is absolutely no data. That's why this is empty. There's nothing in that table. And then you can also have a file view. So when you look at the files inside of your lakehouse, once we have stored data in here, you will see the Parquet files present inside this Explorer view, which we'll see. Right now, again, there's nothing there. And then up here on the top right, you'll notice there's a shortcut to get to that SQL Analytics endpoint. So if you want to actually query your data and examine your data instead of just looking through this Explorer view, you switch to that analytics endpoint, which we could have clicked on the shortcut from the workspace directly. And now we have something that looks a little bit more familiar where we have our schemas, we have our tables, we could have some views that are defined, and then we can run functions and store procedures and so forth. So you could go ahead and actually create a new SQL query here and use SQL language to query this table, which we'll do in a little bit. Thanks everyone for staying on. I know it's getting a little bit later. We'll probably be able to wrap all of this up in about 20 minutes or so. If you want to stay on, thanks for your patience. It's a lot to cover. Looks like we have a question. Jeff asked, is the task flow created automatically for you, or do you need to create it? You need to create the task flow, and you select from that list of possible task flow templates, or you manually construct your own task flow using the categories that are available, and you then put those tasks into that particular into those different sections of your task flow. Hopefully that answers that. I saw the comments from Vic. This was a roller coaster. It is a roller coaster. There's a lot going on, and we could talk about Fabric for a whole day and not be done. So I'm just trying to get you through some of the understandings that frankly took a lot longer than this call for me and others to grasp. So hopefully it's helpful to you. All right, so we have the Bronze Lakehouse. Let's really quickly close these out and go back to the workspace view and take a look. After our Bronze Lakehouse, what we have is an initial processing of the data. And this is not a data pipeline, but this is a notebook. And remember, I mentioned that you can run notebooks in Spark or Databricks or Synapse. Basically, this is Synapse. Running notebooks inside of Fabric is Microsoft Synapse notebooks that are being executed. And so here we have this notebook, which rolls up the weather. So what this does is I have here as a description that it's going to transform the data. This is recorded. Yes, Alex. And Cecilia, will they be able to access the recording somehow if they need to drop or they want to reference this again?
I was just writing about it in the chat. Yes, I will be posting this on YouTube very soon.
Okay, awesome. So you'll see here the roll-up weather notebook here is its intention is to transform data from the weather data table in the Bronze Lakehouse into the Silver Lakehouse by taking the most recent data point for each request. So if we go and open up that notebook, this particular notebook is written in Python language through a framework known as PySpark. You can run different sections of a notebook in different languages, which is very powerful and a great feature of notebooks. You can tie together different sections of your notebook to be in different languages and perform activities that might be better suited for a different language. But in this particular example, it's PySpark. It's using Python. And what I'm doing here is basically importing something known as a pandas data frame library. We're importing some SQL functions. And ultimately, what we're doing is we're running a select star from, I'm basically just showing an example. You could have run this particular query from SQL. The reason it's here is because I want to take that data frame and basically convert it into what's known as a pandas data frame on Spark, and then convert the data into what's known as a Delta format. Remember, we talked about Delta Lake format. So what we're doing here is we're taking the SQL data, the results of the SQL query, and that tabular data, and we are storing it into Delta format inside of the Silver Lakehouse path. And you'll notice that my path to my Silver Lakehouse here has explicitly been added. I grabbed that from the properties of the Silver Lakehouse. I think there is an easier way to reference this, but nonetheless, this is in a more explicit way of doing it, and that's why I'm showing it, because I'm wanting to show how things are actually tied under the covers. So you'll notice that my Lakehouse Silver path location is actually pointing to onelake.dfs.fabric.microsoft.com, and it's pointing to my workspace and the tables inside of that particular Lakehouse. So this path ABFSS is basically Azure Block File Storage specification format, and that's what you're seeing here as the scheme for the URI that's being used. So what's actually happening here in the query? So this is basically a partitioned CTE type of query where we're basically partitioning by a particular column and we're ordering by another. So what the goal here is to take all the data that's in the bronze. We're going to partition it by the request.query column, which happens to be the postal code. So think of it, if we want to pull weather from multiple postal codes, and we're going to pull it multiple times, and our goal is to take the latest weather information from that bronze tier and save it into silver. And that's what we're doing here. So basically, we're partitioning by that postal code column. We're ordering by the column that has the epoch time, which is the number of seconds since 1971, I believe, or 72, and ordering it by that column descending so that I have the most recent, postal code, sorry, the most recent weather for that postal code. And we are generating a row number over each of those partitions so that we can then select the top row number from that result set. And when we run this, this will all make more sense. But just remember, we're trying to take the most recent one, and we're basically saving it to this path, and we are overwriting that particular destination table. So we just keep replacing it in silver. And by the way, that's not an unheard of pattern where you can just basically replace it. So comment from Vic that it totally reminds him of Databricks, 100%. So Databricks is basically a Spark runtime. And so Databricks is built on Spark. They've just extended Spark, added some additional functionality. They actually also have a more expensive Photon engine inside of Databricks where you can pay more. And basically what you're paying for is a completely rewritten Spark engine that is not written in Java. It's written in C++, and it runs faster than the native Spark engine, but it runs Spark workloads. So remember, anytime you see a notebook like this and you see PySpark or Python or Scala, etc., you are working with a Spark type workload, which, yes, is what Databricks is. And this is a Synapse notebook, Synapse, analytics workload, basically, which is all built on Apache Spark. And there are features and functionality in Synapse notebooks in Fabric that are continuing to appear that were only available in Databricks, and they continue to extend it. So yes, this is basically looks just like Databricks. So where were we? We've created this notebook to do the rollup. If we come back here into our workspace, that's what's going to get us into our silver tier and our silver lakehouse. And then we are going to further transform the data using a data flow. So the goal of this demo was to tie together different ways to process data inside of Fabric, not just with a data factory pipeline, because there is more to it, right? You can do things in so many different ways. And so since we already gave a demo of Data Factory on its own, I wanted to show what you can do more inside of Fabric than you can do with Data Factory on its face. So this is a data flow Gen 2 data flow. Again, this is an upgraded, let's call it, version of data flows from Data Factory that you have access to here inside of Fabric. And remember that the purpose of a data flow is to create notebooks like you saw in the previous step that got us from bronze to silver. Data flows are a graphical representation, and you'll notice that it's opening the Power Query editor. It's a graphical representation with the ability to write some code too, using Power Query to then translate that into notebooks that run on basically in Spark compute. That's existing inside of your Fabric capacity. So what is the purpose of this particular data flow? This particular data flow is going to take the source information, which is basically going to be the latest weather data for each postal code, like I mentioned earlier from the rollups. And it's basically going to do a bunch of transformations here where I'm removing columns that are not necessary, and I'm renaming columns to more friendly names. So you'll notice here that, remember, request.query was going to be a postal code that came from the API call, and I would like to rename that. So if I look at my very last step here of all of my applied steps inside this data flow, I have a postal code column now for our next tier of data, right? So that postal code, these are all my friendly names now for all these columns. And I've now strongly typed these columns with the appropriate data type. So I have numerics, I have decimals for Latin long, I have strings, I have dates, date and times, right? So this is now basically what the final schema will look like for my result set. And if we go back out of this to the workspace, hold on a second, let me close this out. It's too kind. All right, so we're coming back in here. That data flow is basically creating my gold tier. And my gold tier is yet another lake house. Could it have been a warehouse? Yes, but it's a lake house, just to keep it simple here. So now you may be asking, well, how do we run all this? This is the key difference between a pipeline in Data Factory or Fabric data pipelines. This is a flow. It's not a pipeline. The flow can have each stage run due to different events or schedules or activities, or you can manually trigger each task inside this flow. And so ultimately what you would have is you would have probably some predefined schedule, or you would be triggering things that you want to run. But basically the goal here is to have a way to chain these different activities together visually, save them into source control, which we can do, and we can save our changes into source control. And there must have been some change. I guess it thinks I had a change inside the rollup weather notebook, and I must have done something that triggered this. I bet you it's just, I think it was when I clicked into something and I hit backspace or something, I don't remember. So there's no actual change. I bet if we committed this and compared it, it would probably not have any viable difference. What I do not like is I do not like that I cannot see the actual change. Like I can't, hold on, what did I just click on? I didn't mean to click on that. I cannot see what actually changed in this particular object. So you're flying blind at this point, which is unfortunate. I hope Microsoft provides a way for us to visually, or at least some kind of text view to see what's changing inside of these objects. You basically have to just know that I made a change, that you made a change, trust that that change is what you are intending to do, and then update your source control. Now, worst case scenario, you update your source control, you can roll back. Okay, you can always roll your changes back from source control. That's the whole point of source control, right? So it's not by any means an irreversible change. You should use source control. I just wish there was a way to visually see it in here and not wait until after I've committed it. And yeah,
left right arrow. What's that left right arrow there? When you went back to that previous up top, one more.
This one.
Up one more icon. The next icon up.
That's this view. These are the change. This is the changes view. If I click on this, it's just showing me which branch I'm in. So there is no real way for you to examine what's actually changing. Now I could argue. Sorry, go ahead.
Source control. Up top, that's the source control.
That's just
Is there
saying
anything
I
there?
have, that's just saying I have a change. So if I click on this, it's going to just pull up this view. And these are my, I have one change. That's all it's basically saying. And if I had any pending updates, they would be listed here, and I'm not sure why they have this view because I have not seen anything here. I think this means if there's changes in source control that I have not synced back to my user interface, if someone else was working on it at the same time. So
you have a question in chat from Victor.
Victor, is source control available for other version control tools, GitLab, Bitbucket? I believe that you can tie it into any Git compatible source control. So if you're using a Git repository that is accessible over the internet, I believe it will work. We can look at that in that separate workspace after I'm done with the demo. So basically, let's just go ahead and run these really quick so that everyone can feel satisfied about this. So here you can actually, on the individual tasks, you could go ahead and look at the settings for them. One of the things you can do is basically look at the schedule. So I'm going to look at the schedule, and I can run it manually or I can schedule it to run. So for right now, I'm just going to run this manually. And it basically starts the run. And I think I have a default. Let me go in here real quick and see. I think I have a default parameter for that pipeline, but I hope I set for a particular zip code. If I didn't, then it would need a parameter to run. Just a second. Yeah, I don't have a default value. That might be why probably nothing's going to happen. Let me run it in here. The parameter could be passed as part of the schedule, but let me just go ahead and pass it in here. So I know 33308 is Fort Lauderdale. So we're just going to go ahead and actually run this. It still thinks I have unsaved changes here because oh wait, sorry. What am I doing? Sorry. It's been a day, folks. Sorry. Let me undo this, discard any changes, and let me go ahead and just run it. And it will prompt me for the postal code. So let me just go ahead and put that in here. And it's going to go ahead and run this. The interface should look very familiar here as far as the actual activities that are queuing and running. And you'll notice that we have an input view and an output view, just like we did in Data Factory. And we have a nice refresh button so that we're not waiting. Oh, we have a failure. Why did we fail? I ran this just fine earlier. Okay, when converting value 0.1 for column name precip from string to int64. Really? How did that? So there was never a fraction in that data type before, but now there is. That's nuts. I've run this demo so many times. Really? Let's try a different postal code that hopefully has a different precipitation value. How about that? Anyone want to offer up a postal code?
33156.
All right, succeeded. Excellent. Let's just take a look at this output. So it looks very similar to Data Factory because it is. It has all the information about it and where it wrote it to. It wrote it to a lake house and so forth. So now let me go into my workspace real quick where I have a notebook at the top here. I have a demo queries notebook. So I'm going to go ahead and open this demo queries, because remember, if we want to query from a lakehouse, we can query through SQL or we can query through Spark. So in Fabric, I'm going to go ahead and I can actually run basically a SQL language Spark SQL notebook to query these different lake houses, or I can use that lake house view that I talked about earlier, which I'll show you, just for comparison purposes. But if we go ahead and we run this, it may take a second for the Spark compute that needs to run this notebook to start up, but now you'll notice that we have a running standard session here. So now this particular part of the notebook is being queued and it will run, and it'll take a lot less time for subsequent runs to take place because our compute is now running. You can stop the compute, stop the session here as well, or it will eventually time out on its own. So here's our result set. So we have 33156 with in the request query column. Like I said, that's going to be our postal code, and it's Miami. And we have the latitude and longitude, and we have some additional information here. Current temperature is 81. And there's a weather icon that we could display on a web interface if we wanted to, and the current wind speed and the direction in degrees and all that stuff. So all in here. We shouldn't have a second row. I hope that's not a result of, it's probably a result of the failed pipeline or something. It's kind of odd. All right, so that's one way to view it, right? View your data. Another way to view your data is basically to come into the lakehouse itself. So let's go do that really quickly. I just want to show you that. So if we go into the bronze lakehouse, remember that the default view is this Explorer view, which if I refresh, it will show that row data in there. There it is. So we do have an extra row in there. And then if we switch over to the analytics endpoint, we can query here using a SQL query if we want. And there it is, right? And let me just come back into that lakehouse view for just a second, because I wanted you to see the files. There should be files in here now. Oh, I think I know why. So it's not going to show the files that are there from tables that are created directly through the, let's call it the SQL or Spark table interface. But you could put files here, like CSV files, and you can actually, they will become tables, which is a pretty cool thing. And then you can examine those files here. There is another way to view the raw files of the lakehouse, of the bronze lakehouse, when they first created this interface, you could see it. You could see both. It seems like they finally took that away, but I believe you absolutely can see that if you connect to the lakehouse using just a standard Azure Blob, type of storage explorer, or through some script, you can absolutely see all the Parquet files that make up your tables. So, all right, let's close this out. Let's come back to our workspace real quick. All right, and so now we've got our bronze data. So now what we want to do is we want to roll up the weather. So we can basically go ahead and schedule a run for this. We could schedule it, to run on a particular interval, but you'll notice that we can't trigger this like we can a pipeline. So I'm going to go into this particular notebook and intentionally run it manually. And if there were multiple notebook steps, by the way, while this is running, the cool part about notebooks is that you can create different segments of your notebook. So in here, you could have additional sections that you've added, and you can run each section independently, and it will maintain state between each section. So you don't have to keep rerunning your entire notebook. You can run your first section, troubleshoot it, know that it worked successfully, and then go and run your next section of your notebook as many times as you need to or want to for for debugging or troubleshooting purposes. But ultimately, you would run your entire notebook or run all when it's run as part of a schedule. All right, so this completed. I know there's some warnings in here. It shouldn't affect the actual output of the data. So let's go back to our demo queries real quick. And let me just let me come in here and clear this out. Isn't this happen? Let me go down here. All right, so we have here our silver query. So I'm just going to query what's happening in the silver lake house real quick. You'll notice that I'm naming the tables differently. So the original table in bronze was weather data. In silver, it's called weather latest because it should only have the latest row of data. Unfortunately, that null row came over, which is going to be a booger. And so if we had results from different postal codes, we would have those and multiple calls to the same postal code. We would only have the latest one here. And then we need to now basically hydrate our gold tier. So let me go into the data flow. And I think you can just do a refresh now, which I think basically just runs it. But you can schedule it as well. So let's see what happens here if I just click on this. I don't have to like go in and edit the whole data flow. Let's give this a minute to run. So you might be asking yourself, if it takes this long to run these different things, then it's really not that fast. Keep in mind that what we're showing here is a workflow of a task flow of tasks that would be probably set to run pretty frequently. And keep in mind that the amount and the volume of data that can be processed through these types of workloads, through data flows or through notebooks running on Spark is substantial. Like you can process hundreds of gigabytes of data within a minute if you really need to, or more. It's pretty powerful, and of course you pay for that scale if you need to process that much, and you can control how much you are paying for by scaling your Fabric capacities. But this is completed, so let's go take a look really quick at our gold. Let's look at our gold query. Where's my little run icon? Why isn't it here? Hold on. Cannot connect to a collaboration server. Let me try refreshing this page. Hold on. There's always something. I love how this constantly shows that we're in the Power BI persona. Even though I'm doing nothing with Power BI. All right, back to gold. I'm going to go ahead and run our gold query here real quick. And we should have, unfortunately, the null row. But you'll notice that now I have postal code, city, state, the friendly names that we have for, for these columns. So that's pretty much it for this particular demo. Let me just come here real quick to the pricing. So data pipelines in Fabric, you pay for data movement, and it's paid for and calculated in capacity units. Anything you do in Fabric is going to be capacity unit driven. And so that's your metric of a billable unit. And this, you're basically 1.5 capacity units per hour of data movement. And there's 0.0056 capacity units for each non-copy activity. And you can obviously pay for any storage that's in OneLake storage. You're going to basically be paying for the storage that's stored there. And that's listed out in Fabric pricing, the pricing information sheet separately as well. So you can bill Fabric as pay-as-you-go or reserved capacity. So I want everyone to remember one thing, if you remember anything leaving this presentation. The cloud can get very expensive. However, once you've established what services you want to use in any of the clouds, we'll talk about Azure specifically, whether it's virtual machines, Azure SQL databases, in this case, Fabric capacities. Once you know what you need at a minimum, you should pay for a 1 or a 3-year capacity reservation, or just call them reservations. But it's not just for Fabric capacities, it's for Azure SQL databases and app services, app service plans, Azure functions, Kubernetes, etc. You pay for reserved capacities, and if you're willing to commit to 3 years, you get a substantial cut in cost. You could save up to 70% in cost if you go with a 3-year commitment on certain products. So, and you can reserve whatever minimum workload you think you need 24/7, and then just pay extra in a non-reserved, amount for anything that you burst or scale above. Dataflow Gen 2 that we showed earlier in this demonstration has a slightly different, billing model, but similar. It's just whether you're using a standard compute or whether you're using a high scale compute will determine how many capacity units per hour are used. So that's it. If you have any questions, feel free to ask them, because I'm happy to answer them. I know you've asked several already, but if you have any more, please feel free. And let me put up this particular next slide. This was from SQL Saturday. This is a page that I have with the slide deck that we just went through, and the demos that I just went through. If Ed's still on here, Ed's probably gonna, and Polly will probably hold me accountable to this. I promised within a week or two after my presentation to get the code scripts that you could use to recreate all this without having to do it all yourself, from Data Factory to Fabric, to get these things uploaded. And I didn't get a chance to finish them to where they could run without some extra steps. And then I had to travel for multiple weeks already for work, so I apologize. I will get back to this as soon as I can. So feel free to, though, reach out to me with any questions. I'm happy to answer them.
No problem. You're off the hook this time.
Yeah.
I've checked it.
Amazing.
Thanks for the
I've checked it about
presentation.
5
It's great.
times, just so you know.
You're welcome.
Thank you so much, Darius.